Hi, this is basically a solution for IPMAT INDORE 2023 paper, the short answer solutions. So let's look at how to approach. We're looking at the best methods that can be used to solve these questions. So yeah, so it's chess tournament. There are four groups, each containing equal number of players. So there are some players here, some players here, some players here, some players here. Okay, and each of the player let there be n number of people in each group. I'm just saying that we want number of players in each group. So let's say n number of players in each group. So that means I'm only calculating for one person. Let's say this one person who is there out here. So what happens in these cases? You calculate for one person, and then you can use this for all the people who are there in the group. So I'm only calculating for one. That becomes easier. So how many people or how many people can I play? So in the same group, I'll play one match with each of the n minus one players. So 1 into n minus 1. So with each person in this whole group, I play one match. So n minus 1 people. So n minus 1 into 1 will be n minus 1. Then for each of these n people who are in the second group, I play two matches. So 2 into n games. Okay. Then this one person will play three matches with each of these n players in the third group. That will be 3n games. And same way we play four matches with each of these n people in the fourth group, which will be 4n. So that means these are the number of matches played with one person. Remember there are 4n people, so into 4n we do total number of matches played. But each match two people play. So that means each match is counted double time. So when you calculate, say one person playing with some other person, calculating same second person playing with one person. So you divide by 2. Similar sum had come in the concept wise. So these concepts you basically do is you calculate for one person and interpolate for all the players. So one person will play so many games. So total 4n people, 4n into 4n, divide by 2 because each match is calculated double time. And this has to be more than 1000. If you calculate this, okay, if you get, this becomes 10n, okay, minus 1 into 2n will be more than 1000. 2 take that side, you get 10n square, okay, minus n is more than 1000 divided by 2, which is 500. Now try to put a value of n and see which value satisfies. I mean, if I put n as 7, for example, you get 49 into 10, 490. 490 minus n will not satisfy. If I put n equal to 8, it becomes 10 into 64 minus 8 will be more than 500. Okay, this will be less than 500. This will be more than 500. So minimum players in each group will be 8. We get n as 8. Right? So if you solve properly, systematically, you can solve it quickly. I mean, the key is to know the right approach and right method to get the answer. Length of a line segment joining two section points. I mean, if you look at diagram for y is equal to x square is this way. Symmetrical over the y-axis. And 4970 minus x will be something like this. Symmetrical round y-axis again. So if I find one point, I can find the other point because it's symmetrical on both the sides. So let's take y is equal to 4970 minus x and this y is equal to x square. Equate y. So basically get x square equal to 4970 minus x, or x square plus x minus 4970 is equal to 0. If you break up 4970 factors, you can make out there is 10, 7, 71 or 70 into 71. So the factors of this basically will be minus 71 plus 70. You break it up as plus 71 minus 70, but because of converting the root symbol, minus 71 plus 70. You can put the equation, but the easier way to do is you break it up as plus 71 minus 70, divide by coefficient of x square and change the sign. It becomes minus 71 plus 70. We're looking at positive roots, so 70 will come out here, minus 70 will come out here. So distance between these two will be 140 because this will be 70, this will be 70, which will be 140. That will be the length. Right? Clear? So basically you want a complete length. If you find a meeting point at one point, one side of the axis, the same will be on the other side of the axis. The total length will be the sum of the two, 70 plus 70, which will give you 140 as the answer. Expand x plus y raised to n. When you expand x plus y raised to n, the coefficients comes as nc0 for first one, then nc1, nc2 and so on. So you have three consecutive coefficients. So one way of using three consecutive coefficients, you can use NC, let's say R minus 1, NCR, and NCR plus 1. Three consecutive coefficients, because this keeps on increasing. If I write this, it becomes n factorial upon n minus r plus 1 factorial into r minus 1 factorial. The first one. The second part becomes n factorial upon n minus r factorial into r factorial. Third becomes n factorial into n minus r minus 1 factorial into r plus 1 factorial. N factorial gets cancelled everywhere. So basically, if you reverse it, you get n minus, you can, okay, so this is the ratio you get, 1 upon 1 upon 1 upon. And this is nothing but 1:9:63. Now take the ratio of first and second. If you take a ratio of first and second, which is 1 and 9, so what you get? 1 upon n minus r plus 1 factorial into r minus 1 factorial upon 1 upon n minus r factorial into r factorial. This goes on our top, becomes n minus r factorial into r factorial upon n minus r plus 1 factorial into r minus 1 factorial. Now what is r factorial? R factorial can be written as r minus 1 factorial into r, and n minus r plus 1 factorial can be written as n minus r factorial into n minus r plus 1. So if you look at r minus 1 factorial gets cancelled, n minus r factorial gets cancelled. So what's left is r upon n minus r plus 1. And that, if you look at in the first ratio, is 1 upon 9. Solve this, you get 9r equal to n minus r plus 1. Bring it on the other side. So 10r minus n minus 1 equal to 0. So you get 10r minus n minus 1 equal to 0. First equation. Similarly, take the second equation. Okay, because this ratio, if you look at, remember, this is 1 upon 9, what we got, 1:9, the first two ratios. Now you can take the second and third. Similarly, 1 upon n minus r factorial into r factorial upon 1 upon n minus r minus 1 factorial into r plus 1 factorial is equal to 9 upon 63 or 1 upon 7. If you solve again this n minus r factorial, n minus r minus 1 factorial will get cancelled. So what will be left is n minus r, and r factorial will get cancelled. What will be left is r plus 1 will be 1 upon 7. If you solve this, it becomes 7r plus 1 is equal to n minus r. Bring it together, you will get 8r minus n plus 1 equal to 0. Okay, bring it this side. So 8r minus n plus 1 equal to 0. So you need to remove the value of r to get a value of n and then try to solve it. Right? So this becomes, 7r plus 7. So bring 7. So if you multiply this by 4 to make it 40r and multiply this by 5 to make it 40r, solve it. So you get 40r minus 4n plus 4 equal to 0, and here it becomes 40r, okay, 5n minus 5n plus 35 equal to 0. Subtract the 2. When you subtract the 2, 40r will get cancelled. You will get basically n which will be left, okay, and 39 would be the value, because this becomes minus 4. So 35 will become n minus 39 equal to 0. You get n equal to 39. That will be the answer. So a little tougher. I think this is one of the toughest sum in this particular test. But yes, if you do it systematically, 2 at a time, you should be able to get the answer. But technically, this sum should be kept for the end because the calculation involved is high. The rest of the sums could have been solved faster, and this could be kept in the end. But yes, binomial expansion, expand binomially and take 2, 2 as a ratio and then try to find the answer. Right? Hope this is clear. Thank you.